Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan bin Muhammad Yusuf, and today I want to share my experiment in thermodynamics T2, which is Boyle's Law. Objectives is to investigate the relationship between the pressure and volume of gas with constant mass at constant temperature. So objectives is the main reason why this. So introduction. In the year 1662, Robert Boyle published the result on his experiments on the relationship between volume and pressure of a gas. This is why the first ever gas law was named after him. So this law states that at a constant temperature for a fixed mass, the absolute pressure and volume of a gas are inversely proportional. So this is P equals to 1 over V, right? So from the equation, the pressure shall increase when the volume of gas decreases and vice versa, given that the temperature of the gas and mass of the gas is constant. Okay, so for the way that this equation works is the temperature of the gas and mass of the gas is constant throughout the process. Apparatus. So there are 24 components in this experiment, which involves valves, compressor, pressure sensor, temperature sensor. We have also control panel. We have emergency stop button and a few more. So procedure. Okay, we start with startup, which is a set of procedure to be done before the experiment starts. First is to connect power supply. Then we have to go to quick inspection. We also have to ensure that all valves are initially closed. And next is we of course have to switch on the main power supply. Procedure. We have to perform the startup procedure. Then we have to fully open the valve BV101. We have to record the initial pressure. Next, we have to switch on the air compressor. Right. Next is when the pressure in T102 reaches 0.8 bar. We have to switch on we have to switch off P101 and close BV101. We have to slowly open the valve GV101 and ensure that the temperature does not change as volume of air changes. Okay. Next, we have to close GV101 when the oil level reaches 2.5 liter. Okay, we have to record the reading and together with the temperature of air. So next we have to repeat step 6 for different volumes, which includes 2.4 liters, 2.3 liters, 2.2 liters, 2.1 liters, 2 liter and 1.9 and as well as 1.8 liter. So we have to record all pressure and volume measurements accordingly and perform the shutdown procedure. Okay, this is to give a better look. Step 2, step 4, step 6, and step 9. 2 is to open the valve up here. We have to also switch on the main control. We have to switch on valve, open up the valve here again, and then we have to record the data obtained. So this is the procedure since T2 has two sets of experiment. Next is to experiment with the expansion of gas. We have to perform startup procedure, open valve BV102, record initial pressure. Then we have to fully open GV101, operate the vacuum hand pump P102 until the volume of air reaches 2.6 liter. Then we have to wait for the pressure reading to stabilize. Then we have to repeat with a different set of volumes, record, and then perform the shutdown procedure. This is the better way to look at the procedure. Okay, now is the shutdown procedure, the set of procedure that needs to be done before we finish with the experiment. So we have to ensure the pump is turned off and all valves are closed. Next, we have to fully open GV101, and if the tanks are under pressure, we have to open two valves, VV102 and GV101, and operate vacuum hand pump until both tanks reaches 0 bar, and then we can close all valves. If the tanks are under vacuum, we have to open BV101 and GV101, switch on P101 until both tanks reaches 0 bar, and switch off P101 and close all valves. And then only we can switch off the main power supply. Calculations. So the calculations is of the way to find theoretical pressure for experiment A and B using certain sets of equations like P is equal to M over V, PV is equal to MRT, and P1 V1 is equal to P2 V2. Okay, this is my calculation of R value. This is my sample of calculation. So this is how I calculate the theoretical value for experiment A. Pressure is equals to mass over volume, and this is how I find mass. So it's equals to 3.23 times 10 to the power of negative 3. So and then I'll just substitute into equation PV is equals to MRT, which equals to 3.23 times R, which is 0.287, and times T, temperature, which has been changed to convert to Kelvin, and divided by the volume. So the initial temperature is pressure is 1.09 bar. So calculations for theoretical pressure with V is equals to 2.4 liter. So P1V1 is equal to P2V2, and I'll just substitute the values there. 1.09 times 2.5 is equal to P2 is equal to 2.4, and we'll get the pressure of 1.14 bar. Presentation of data. So there are two sets of tables. First is the result for the compression of air, and second is the result for effect of expansion of gas. So this is graph plotting for experiment A. Just gonna fill in the values. So from these values, this set of values, I'll turn into a chart using line bar chart, and then just substitute the title. Oh, sorry, and then just come up with a title. And this is in a way we could see that it's linear. And A. This is the plotted graph. Next is the way to plot the graph for experiment B. Sorry about the volume there. So what I did is there's volume, experimental pressure, and theoretical pressure, and all this data will be converted into chart. Hold on. Oh, convert into chart. Then I have placed the title and title. Right, then I'm gonna write my name there to show that this is mine, my modifier also, and my matrix ID. That is the end result, the plotted graph. So as a conclusion, this experiment is successfully studied and the system obeys Boyle's law. From the graphs, it can be concluded that the pressure of the gas in column is inversely proportional to the volume of the gas at a constant temperature for a fixed amount of gas. As Boyle's law states that with a decrease in the pressure of a gas, the volume of gas increases. So when the nozzle of spray paint is pressed with a sudden decrease in the pressure of a gas, the volume of pressurized gas increases. So this is the application of Boyle's law in everyday life, which is in use in spray paint. I think that is all from me. Thank you. Have a nice day. Assalamualaikum warahmatullahi wabarakatuh.